All right, so we're in Windows world. I've been spending a lot of time here. I mean, it's my favorite place to come, Building 26. You're in Windows now. Who are you?
Mark Russinovich. I'm a technical fellow in Core OS.
Okay.
I came to Microsoft about 6 months ago when my company, Winternals software, was acquired.
Okay. Yeah, no, we've heard of that, Wininternals.
Wininternals is a website that Bryce Cogswell and I started about in 1996, I guess.
Okay.
And it was, we started to do Windows NT stuff and wrote some tools, wanted a place to put them up so that other people could use them. It's no fun to write a tool when you're the only one that's using it.
Exactly.
And the web was getting popular back then, so we threw up a website. It was called ntinternals.com, and we started to put those tools up, and even by standards back then it was popular within a few months. And it's just been growing and growing and growing ever since. It's still growing in popularity, even now after it's become a Microsoft Tech Center on TechNet.
Excellent. I mean, you clearly understand Windows probably almost as well as the Windows people understand it. I mean, I guess that's fair to say. If you're writing low-level tools for NT, I mean, you have to know what you're doing, what the system's doing.
Yeah, and that's actually one of the reasons that I did write those tools, is so that I could see what the system was doing. One of the first tools that, actually the first tool that I wrote for Windows NT was sorry about that, it was a utility called Control to Cap, which just swaps the caps lock into a control key. And I'm running it even now on this keyboard, because I'd come from Unix. Through grad school, was working on Unix systems, and on Unix keyboards, that's a control key, not a caps lock key. So I was like uncomfortable on a PC keyboard. How can I get myself comfortable? Well, I'd really like this to be a control key, and there was no Windows mapping UI power tool or anything back then. So I realized that I could, if I wrote a driver that would intercept the caps lock and switch it into control, then that would be something low level enough that it would act like this Windows would see it as a real control key. And so the first tool that I wrote was a keyboard filter driver. It sits in the kernel and it watches the keystrokes come in from the keyboard driver before Windows gets them, and then looks for the caps lock and changes it into control. But then after that point, I was like, oh, this filtering model is really cool. What else can I see going on inside of Windows? And so wrote a tool called FileMon with Bryce Cogswell. FileMon, a lot of people that are familiar with Wininternals have heard of FileMon. It's a tool that watches what's going on in your file system. Every process, what reads, writes.
It's an awesome tool.
Thanks.
Most
Have
developers
you used it?
Yes, I have used it.
So that was the second tool that we wrote for Windows NT. And that tool I wrote just because, let me explore the filtering model, and this accomplishes two purposes. One, in the process of doing this, I learned about Windows. Two, I learned how Windows operates, because writing the tool, I learned how filter drivers and the file systems work, and then once the tool's written, I get to watch what's going on and learn what's happening.
Cool. So, I mean, why Windows? I mean, it's an interesting question. Yeah, I mean, why didn't you stick with Unix?
So, the way that I got into Windows actually wasn't a direct jump from Unix to NT, but actually I stopped at Windows 3.1 and Windows 95 along the way. Back when I was in grad school at Carnegie Mellon, my PhD thesis was on fault tolerance and putting mechanisms into the BSD kernel that would allow you to put fault tolerance and fault recovery policies on top of a base OS.
Cool.
In fact, it was like the mechanism that I put into BSD was like system call hooking, which I took advantage of later with the tool called Regmon in Windows NT, where you'd intercept system calls and then you call out to your policy hooks and they do extra things. And the things that I did for Unix were, for example, checkpointing and rollback, so that you could run your Unix system. If you had a problem, the system crashed, you could reboot, restart at the previous checkpoint, and then it would even replay your mouse and keyboard input up to the point where you wanted it to stop or the system failed. Windows 3.1 was the popular desktop or OS at the time, consumer OS, and had a notorious reputation for reliability. And people's system locks up or crashes all the time and they lose stuff. So I thought that was a great opportunity for commercializing that and putting checkpointing and rollback into Windows 3.1. So I learned Windows 3.1 internals. And then Windows 95 came out and I learned Windows 95 internals to do it there, and then Windows NT 3.51 came out. and that's when I noticed NT line. I'd heard about it before, but
Sure.
then I was like, the commercialization stuff didn't go very far because really you need support from hardware vendors to do that kind of thing. But when I saw Windows NT said, they've got the server operating system, workstation operating system, and then with a UI that's the same on the workstation and the server. And it's the same UI as the consumer version of Windows 3.1. So they've automatically got this user base that's going to be familiar, going from their home systems into work and using the corporate versions of the software. So,
Sure.
whereas Unix is you basically have to get a degree in Unix to go do Unix stuff.
Sure.
So that's where I said this is the future of operating systems.
Cool. So what is it about NT that makes it so stable, in your opinion?
It's funny that you asked that question because 5 years ago you probably would have asked it slightly differently or avoided that question, right?
Yeah.
What makes it different that it's so stable? Different than what? Let me ask that.
Well, I mean, let's talk about. I mean, clearly an operating system that has like Windows 95 or Windows 98 or even Windows 2000. Of course, Windows 2000 is based on the NT infrastructure. But what is it about the architecture that NT? When we think about NT kernel.
Yeah.
Was there not a user mode and kernel mode in 95?
No, there was a user mode and kernel mode, but once you got into user mode, there was no boundaries between processes. So when you're running, you're log into your system, there's a whole bunch of processes running. There's Explorer, and then there's Notepad, and the other processes that you run, and they're all in their boxes. So they can't mess with each other without going out of their way to do so, and they can't mess with the kernel. In Windows 95, there was no boundary. Even though there was two modes of operation, kernel mode and user mode, you could just mess with the kernel without anybody getting in the way, and they could mess with each other accidentally. I mean, that's most of the time in Windows 95, it was accidental problems where you have a process and it's got a bad pointer, and that bad pointer now references something in the kernel. And so it goes and writes some text there because it thinks it's a buffer that it's going to be storing some text in. It actually happens to be overwriting a driver that's in the kernel, and that driver starts executing the system. Gets blue screens.
So it kind of does away with the notion of security.
Right, reliability too.
Yeah.
There was no security and no reliability.
So now
you get
that's not the case in Windows Vista. I mean, we've been covering a lot of stuff on Windows, and one of the things that it seems clear to me is that Windows Vista is our most reliable system today. It is our most secure system today. And so some of the things to ask would be, how can we say that? Why can we say that? From a operating, I'm an operating systems guy. I love operating systems. You're an operating systems guy. Let's talk about, from an operating systems point of view, why is Vista, why can we say things like that? Like, we're not marketing, but I mean, why can I say, I think Windows Vista is the most reliable version of Windows yet? Or most secure.
Yep. So there's two ways to look at it. One is the way that it was developed, which is from start to finish the secure development lifecycle (SDL), which Michael Howard's the big. I don't know if you've covered Michael.
Yeah, we've had Michael on here before.
So I guess people can go look at his channel and interview and learn about SDL. But Vista was done with SDL, and SDL means that at every step of the development process, you're looking at, are we doing this stuff securely? Are we handling strings and buffers that are coming in from outside securely? And if you're not doing that from the ground up, you don't have a good degree of confidence in how you were handling that stuff, and that means that there could be cases where you're missing it. And any case where you miss it and you're communicating with some untrusted outside location is a potential machine compromise. So that's one reason that you can say it's the most secure. But then you go and look at the features and defense in depth kind of things that have been added into Windows Vista that weren't there previously, and that gets you even further, like address space layout randomization, ASLR, where Windows XP SP2 introduced something called data execution prevention, or DEP, which locks down areas of memory that should never be executed and marks it as non-executable using hardware support. So a virus comes in across the network, infects a service, and most of the time it's through a buffer overflow someplace in the heap or in the stack. And the virus tries to take advantage of that buffer overflow by putting code in the heap or the stack that it's then going to cause the program to jump into and